Hello, everybody, and welcome to AMS Weather Band's latest webinar, Summer Season Review, Wildfires, Extreme Heat, and Beach Safety with Robin Heffernan, Richard Grum, Bruckner Chase, and moderated by Doug Hildebrand. Now, before we begin today, as always, I would like to address some of the guidelines for our attendees. If you have any questions during the webinar, folks, please put them in the Q&A option at the bottom of your screen to the left of the chat button. Questions for speakers submitted through chat will not be considered. So please make sure that your questions go to the right one or the right option there. We will have some specific time for questions from the audience after the presentation, but we will also have opportunities to answer questions that pop up during presentations as the flow of the show permits. Now I would like to introduce today's moderator. So Doug, thank you very much for joining us. Doug Hildebrand, with 20 years in the National Weather Service, leads programs promoting weather readiness and resilience. As chair of the AMS Weather Band Committee and through various roles, he's driven collaboration, drafted AMS statements, and worked to reduce lightning-related deaths. So, Doug, thank you very much, and I give the floor to you.
Thank you, Gideon, and thanks to our speakers tonight, and thanks to everybody joining us. You know, we try to touch base every 3 months to provide a seasonal review, and lo and behold, here we are, November 1st. Pretty much everyone east of the Mississippi are going to be under freeze warnings. Here in DC area, we're definitely going to get our first below freezing night. So let's start talking about this past summer. We have our great 3 speakers here, really focusing on the fire weather season, the extreme heat season of summer, and, you know, to escape the heat, a lot of people go to the beaches, and we're going to be looking back on the beach safety, rip currents, and how we can really reduce the tragedies that occur at our nation's beaches. But first up, Robin Heffernan. She is the National Weather Service Fire Weather Services Senior Advisor at the National Interagency Fire Center. I had the honor of visiting Boise, back 15, 16 years ago, a very special place, especially walking the memorial there for those firefighters who have lost their lives, given the ultimate sacrifice. And so with all that has happened this summer, Robin, you know, I guess my reflection, and I'll hand it off to you. I took my family to Hawaii this past June. In fact, spent 5 days in Lahaina. So I'd love to touch on the Maui fires. But also here in the DC area, we experienced multiple smoke events from the widespread fires in Canada. And, you know, you can correct me if I'm wrong, but, you know, out west, they sort of benefited from the record snowpack. When it comes to a typical fire weather season, you can obviously provide more details on that. But one of my questions sort of toward the end is how do all of the atmospheric river events that we saw the past few seasons from spring into winter, along with that record snowpack, how does that sort of tee up fire weather seasons to come? So Robin, take it away, please.
All right. Thank you, Doug. I'm going to share my screen here. I do have a few slides for you. All right, just introductory slide there. So yeah, you hit on the 2 major impacts really from this summer fire season, which was really the Maui tragedy in the Lahaina area there. And, you know, I know you weren't probably thinking about fires when you talked about the tragedy at beaches, but sadly this year that turned into a reality for folks in Lahaina on the island of Maui, where we saw a very rapidly developing fire situation impact the public in a very dramatic way. Estimated death toll is around 97 deaths is what I last heard from that event. And, you know, overall, we can say that this fire year so far and the summer fire season for many of our Western states really was not nearly as busy as we've seen in previous years, and I'll show you some numbers and stats. But as a whole, it was a rather slow fire season. But the impacts, Doug, that you brought up, and I'm showing on the screen right now, really tell the story that even during a slow year these days, we cannot escape the fact that these impacts are significant, and it really only takes one significant event that can happen in any given year, depending on the pace and scale of the fire intensity. And they're not uncommon anymore, and we're seeing them every single year. And then, of course, the smoke impacts across much of our country, but particularly in areas of the country that don't typically see smoke impacts. In the West, we are very, very used to, not that it's okay, we're not okay with it, but we are very used to seeing smoky skies in the summer with the fires that develop across the Western US. And many areas of the country, like the Great Lakes area, the Northeast, Washington, D.C., got a flavor of smoke this year from the Canadian fires. And I think it was eye-opening to many folks across the country as to what the impacts really of fire are, and that they extend and expand long past the flames, right? That's the near-term impact that we all think about, but really the long-term impacts go far, far beyond that. And I think this season really showed us those impacts. So kind of just showing kind of a snapshot here of what those impacts are across areas. And it's, like I said, we think of the public safety there on the left as like the most common thing, but stemming from that is the air quality that impacts many, many more people than the flames ever will. And the utility companies and the insurance industry, right, that are now really are trying to protect themselves and our communities from wildfire. But they are too being very challenged, just as we are in the public service sector. Water quality, something we don't think about much, but really the watersheds, the airsheds, the watersheds are impacted. Watersheds are impacted for many years beyond when the fire is out. And then, of course, all of these impacts, what they play into our economic situation. So looking into this year, specifically, and Doug, like you were saying, what were the climate impacts or the climate variables that really played into this season? Well, long before the season starts, we have the recipe set up for what the fire season is going to be, and it just is a determination of how it really plays out. So if you look at this year, like Doug had mentioned, we had a very cool and very wet winter across the West, with very significant snowpack levels and snow water equivalents in those snowpacks, around 250% in some areas of the Sierras. And then we went through the spring months, and we continued to see those frequent atmospheric river events continue to bring precipitation to much of the West. And then what I'm showing on the screen here, these are the summer months here, June, July, and August. Departure from normal temperature on the left and precipitation on the right. And you can see, nothing really stands out to you, right? I mean, in some areas you can see some dry area there in Texas, but by and large, we kind of have a mix of kind of normal conditions. But it really was how these normal conditions played out that spoke to what happened across our fire season. And what really determined where our fires were this year really had to do with our fuel moistures, mainly our live fuels, but also some of our soil moistures and some of our larger dead fuels. And what we tended to see was throughout the course of the summer, we had some areas of what we would call flash flooding. It's kind of like a flash drought, where we had these periods of deep and extended drought across a moist area of the country, the Southeast, Texas, Louisiana areas, where they had some record fire activity across those areas just because of the significant drought that was sitting into that area of the country. The Northwest, you can see represented here on the drought monitor, was developing drought as we went through the summer months, and they had active fires, but all within what we would consider the realm of normal, meaning that they didn't require a whole lot of resources from outside those geographic areas to come in and help with those fires. And then, of course, like you can see here on the drought monitor, with Hawaii there representing the significant dry conditions there, and of course the impacts we saw when that combined with some dry and windy conditions across Lahaina and the active fire there. So what did this look like statistically for this summer? Got some statistics on the left here with regard to wildfires, and on the right with regard to the National Weather Service response to that. So total fires overall were about 99% of the 10-year average, totaling 48,681 as of this morning of our number of fires. So you can see, as far as fire starts, it was a pretty average year with regard to that. What's significant, though, is the next bullet when it comes to what did that actually result to in acreage? How big were these fires? And really, the acreage across the country was only about 38% of the 10-year average. And many of those acres occurred, like I mentioned, in the southern area, Texas, Louisiana, and the southeastern states during periods of dry activity. So, so this is once again speaks to the moisture that was held in our soils and in our larger fuels such as timber, that really didn't allow for some of these fires to grow very quickly, which we're very grateful for this year. But what that resulted to in our response is we still had a very, very active year as far as the National Weather Service and how we were able to respond and support these wildfires. We had 91 IMET deployments this year, which was and 143, excuse me, of 91 qualified IMETs this year that were ready to respond. In the deployments this year were 143, which, as you can see, is well above our 30-year annual average of 117. And what's most significant here with the numbers on this page is really the number of RX HARRIS prescribed burns. You might hear them be called beneficial fire, prescribed burns. These are activities that take place, fires that are deliberately placed on the landscape during times of safe and low fire behavior, so that we can try to remove some of the underbrush and fuels that have built up on the landscape. And historically, the Weather Service has maybe deployed to one of these fires a year historically. But as an enterprise, the land management agencies are really taking a hard look, and Congress has invested in these types of fuel treatments to be done on the landscape, and in much higher levels than they have in the past, to try to get a handle on this wildfire crisis. And the Weather Service has been called upon to support those so that they are constructed in a safe manner. And so we had 21 prescribed fire or beneficial fire missions this year, which is quite a bit more than our typical 1 per year average. And then out of those 143 missions, 4 of them were to support specific to smoke. We have a cadre of meteorologists that are qualified specifically in that area for smoke support. 4 of them were for non-wildfire FEMA type. And then we have 25 of our missions were for our trainees going out into the field and being trained up to be certified meteorologists. And we're continuing to increase our capacity to fill not only wildfire deployments, but as we're talking about here, the prescribed fire, beneficial fire deployments, to make sure that those are done in a safe manner. Just looking here to kind of see what our deployments typically look like compared to normal. This is our number of missions here in the black line, and the green area is, the dark green is a normal line, and then the lighter green is a spread of 1 standard deviation from that. And you can see, even on a slow year nationally with regard to fire activity, and particularly fire acreage, we had a decently busy year as far as deployments and supporting these fires. And the site-specific forecast, our spot forecast, which is what our partners request for either beneficial, prescribed fire and or wildfire activity, was significantly above normal as well. So it just resulted in continued busy activity even during down years because of the impacts we're seeing. This is just a graph of our normal IMET deployments on assignment per day. And then just a little bit of a breakout here of assignments per agency that the National Weather Service supported this year. Largely U.S. Forest Service this year. Part of that has to do with the wildfires, but a lot of that has to do with the prescribed fire activity happening on Forest Service land. And once again, the support that has been called upon NOAA and the National Weather Service to make sure that those are constructed in a safe manner. So, like I said, a little bit of a unique year here. Overall, not a significant year as far as numbers go, but as far as impacts, we continue to see those significant impacts, and they continue to increase year after year. And as part of the bipartisan infrastructure law, Congress had asked for a wildfire commission to be stood up and develop reports for Congress to recommend how we can change our way of doing business in wildfire. and NOAA was part of that effort. The report came out on the 27th of September. The Wildland Fire Mitigation and Management Commission is the name of that, if you want to Google it and look at the report. It's over 300 pages, and there's 148 recommendations of unanimous across 50 members on this commission, representing federal, state, local, to really help us move forward in how we respond to these fires, but more importantly, how we prepare for them and make sure that we're resilient to the impacts from them. Thank you.
Wonderful, Robin. Thank you for that. And just for all of our attendees, that if you have questions, feel free to throw those questions into the Q&A feature. You can do it now. You can do it later. We're going to have all of our speakers speak first, and then we'll have more of a consolidated Q&A the back half of the hour. So thank you, Robin. Next up, Rich Grum. Rich is retired. Congratulations, and thank you for your long, distinguished service in the National Weather Service, making State College and the forecast office there your home. I'll add that, Rich, if I had to create an all-star operational, forecaster team, you would be on it. So with that, how was the synoptic patterns and the extreme heat and everything else that was interesting about the weather this summer?
And I ended up on the wrong slide. So I have a review of the summer of 2023, pretty much big ridges and fires and floods. And talking about how nice it is for the summer. I walked 6 miles in the snow today, so that was pretty nice. So this is a global overview of the summer, and due to the emergent El Nino,
Rich,
you can see.
Hey, Rich,
yes.
Can you either share your screen or Gideon?
Yeah, somebody else
There
had the
you are.
screen apparently. So,
All right, we have it.
like I said, okay, the summer of 2023 and ridges, fires, and floods. I mean, this is the image that I was showing how warm it was globally this year. It was the hottest since they began taking records in 1888. And you can see the impact of the El Nino that was developing, and the heat that came up through Mexico into the United States and across northern Canada where the fires were. And I think a version of this image was shown in the previous presentation, but you can see how warm it was in the southern United States, a little bit cool in the Ohio Valley, warm in northern New England, and warm in the Northwest. And it was pretty hot, of course, across the southern U.S., as most people who live out there knew. And you can see the precipitation. And I have a house in New Hampshire, southwest New Hampshire. We had 16 inches of rain in the month of July. And but New England was very wet, so most of the Northeast was very wet, and it was wet around the top of the ridge coming out of the plains and into the southern United States, and it was dry in the southern United States. It actually was wet because of the hurricane that came into California late in the summer that changed the pattern here considerably if you look at individual months. So a couple of one big events made a difference in several locations. The continental United States was hot over much of the country. It was wet in the Northeast and the Southwest and the Western Plains. Some big events. We had a couple of really big severe weather events. There was a big tornado event on the 20th. We had a period of several tornado events on the 20th to the 26th of June. There was a big event that had over 1,400 reports on one day on 7th August. And I'll briefly show one multi-day event where there were total over 1,600 reports of severe weather. So we had this summer that. Oh, then it was really, of course, smoky in the Midwest and the Northeast. We had some high air pollution days here. I'm a cyclist, and we had 2 days where they claimed the particle count was too high. You couldn't bicycle, and our bicycle club had to cancel some bike rides. But the reason, of course, we had these big ridges, and the big ridge dominated the summer over the southern United States and dominated the weather of course, most of the United States. And there was a big ridge in Canada, especially in June, that led to the dry conditions, the fires, and the smoke. And the big ridge over the southern United States that really help with that July heat. The heat really seemed to damper after about 8 August. This was the mean pattern over the United States. You can see that real dominance of tropical ridge over Mexico and the Southwest United States, and this secondary ridge that was up in the high latitudes where it was really dry and where we had all the fires in Canada. So that really impacted our weather. And most of the severe weather was on the northwesterly side, or the northeasterly side of the ridge. And then we had a hurricane eventually sneak up on the backside of the ridge. And this was a map of the fires that in Canada that made all the smoke into the Midwest and the Northeast United States. And June was really smoky here in central Pennsylvania. And I was in New Hampshire, that had some smoke up there too. And it brought air quality down. And we saw an image in the first talk of New York City with the really bad air quality. So it was kind of unique for people I think in the Northeast, especially to be impacted so many days with smoke from the Canadian fires. And in July, there were several big events, as I talked about in severe weather, what I would call over the ridge severe weather events, where you, in the flow over the top of the ridge, you get severe. And we had 1,358 reports of mostly wind damage. And this event occurred over the ridge with a strong low-level jet, which I won't be able to show you. But the numbers of the event were really high. It was clearly a high impact with a large population density. And these events really were unheard of years ago. So it used to be a big event was like 300, 400 severe weather reports. But to get events where you're getting like 900 or 700 reports in one day is kind of unprecedented. And I think that's a kind of an eco-modification issue, if you will, where people have cell phones and videos and social media. And so the number of reports of severe weather has gone really up. And I don't think the amount of severe weather has necessarily increased. It's just our ability to hear about them has increased dramatically. So this is the reports on the 28th. There were some tornadoes in Illinois and the upper Midwest there. And then this system went a little further south. And you can almost see that arc of the severe weather event coming over the top of that ridge that was persistent in the Southwest United States. There were several events that had this look to it and several multi-day events like this. But this is a pretty large number of severe weather reports. And then, of course, in August, we had this rare hurricane that became a tropical storm when, of course, when it got to California. It tracked up off the coast of Mexico, up into California, and it came up the backside of the ridge. You can see there was a huge subtropical ridge located over the central United States. And as you can see the trough and the abnormally low heights associated with the tropical storm as it moved into California and then up and around this huge ridge, which created a mid to late August precipitation event that made it wet in the extreme Southwest United States for the entire summer. This is the precipitation in the two most heavy rain periods that occurred. You can see the heavy rain in Southern California into parts of Nevada, and you can see the arc of rain went all the way up into Idaho and Montana. Some people actually think that was one of these pre-events, but it was clearly a big plume of tropical moisture that went way over the top of the and up the west side of a big subtropical ridge. It's the second day of precipitation. You can see the precipitation actually got into the Dakotas associated with the plume of moisture around the huge subtropical ridge, but the focus was the heavy rain in California from a tropical cyclone. And this was another hurricane that snuck up late in the summer, came up into Florida. It made a landfall in a place that doesn't always get a lot of hurricanes. It was a pretty uncommon place to see hurricane landfalls in the last 50 to 100 years. And it produced a pretty good swath of heavy rain that ran from Florida all the way across the Carolinas. And so that added to the precip there, making it a little bit wet in the generally dry area that we showed in the earlier map in the Southeast United States. So, and then there was the August 8th Maui wind event. This was like a fire, but probably related to an eco-modification event where these wildfires were a series of fires that burned parts of the island of Maui in the United States in August 2023. The fires began on the 8th of August. They struck hardest in the historic town of Leahana on Maui's western peninsula, reducing much of the town to ash and ruins. I think Doug made the statement, was there. I was there in May, and I actually was I was surprised at how much grass there was there. I stayed just north of Leahana, and I think every night, except for one, I either ate dinner or walked around in Leahana and visited that famous banyan tree. It was a beautiful town, but the street was lined on either side by really old, late 1800s buildings with wooden boardwalk for sidewalk. So instead of having pavement, they had wood. And so that was a town that was really easy to burn, I guess you'd say. But so I think this was kind of a man-made disaster due to the ecological modification. In the 19th century, farming destroyed a lot of the indigenous and drought-resistant trees and grasses. They were big into sugarcane production. These invasive grasses came in, they're not drought-resistant, and they clearly modified the environment. Then you had the power lines, which are a known potential issue. The people in Hawaii knew this. It turns out there was a plan in effect to eventually mitigate the potential of arcing and stuff with power lines that was never implemented. But basically, this was a high wind event that had this ecological modification issue that created this powder keg that blew up and created this disaster. And I actually, when I was in Maui, I used this Maui's driving guide, and I had that app on my phone. And when I was driving around in May, believe it or not, in the dead time on the app, it would tell you about the history of Maui, and they talked about on the app how and all the drought-resistant crops and plants that were natural to Hawaii, the trees and grasses, were replaced by these non-indigenous species, which I thought in retrospect was kind of weird because these invasive species really ended up being a real problem this August. So, and they actually found out what the different kind of grasses that grew there were. But once they got rid of the sugarcane production, these wild grasses really took over. This is an image showing the flow. I boiled it down to one image. You can see the box kind of highlights where Maui is. This is tropical cyclone down here, Doria, that people thought initially was the cause of the fires, but really there was this abnormally strong anticyclone and these anomalous easterly winds that went through past the islands, creating really what ended up being a downslope windstorm. And anybody who's been to Maui knows in the northern part of the island, just to the east of Leahana, there's 5,000 to 6,000 foot mountains. And if you go much further south of the island, there's this larger volcano that goes over 10,000 feet. And if you ever drive up that volcano and you have a clear view, take the pictures, because when the clouds roll in, all you get is white. And so this was a simulation that was shared on the Albany map by Cliff Mass. They ran a simulation of the strong easterly winds over Maui for the event. And you can see these anomalous easterly winds hit the mountains of Maui, and then they created this huge downslope windstorm at Leahana, which created the conditions that were strong enough to affect power lines. The power lines hit the grass, and then the grass literally burned like a wildfire. So, but these mountains to the east, they're 5,000 to 6,000 feet up. It's really one big kind of mountain, an old volcanic mountain. And the more famous volcanic mountain that's twice as high is to the south. But you had these 4 to 5 standard deviation above normal 925 winds, and the power lines and the grasses did the rest once they were sparked by the. So this is the heat. I think the heat this summer peaked in the United States around the 28th and 30th of July. And if you look closely at this particular image, you'll see the temperatures in Kansas, Nebraska, and Oklahoma are between about 110 and 117 degrees. This was a GEFS long-term forecast, and anybody who was forecasting the summer knows that the GEFS at longer ranges had these ridiculously high 2-meter temperatures in the model. That really never verified, thankfully, but it actually was a really hot day, and temperatures did get well into the triple digits over the same general area. The purplish colors kind of show all the places where it was above 100 that day, but thankfully the temperatures were 8 to 11 degrees Fahrenheit cooler. If 111 versus 101 is cool, over the plains and the southern plains on that particular day. But this was a known forecast issue that the GFS was over forecasting 2-meter temperatures. But still, this was one of the most widespread 100-degree temperature days of the summer. As I said earlier, it kind of the number of 100-degree locations and stuff on individual days really diminished after the 8th of August. And if Phoenix is a nice place to look at, this is a plot of the days where it was above 100, the daily temperature you can see where it was above 100 degrees. And I played around with the data, and it was the second most days of 100 degrees, 66 versus 76 in 1993. And it ended on August 8th. You can see it cooled off for a couple of days. It was the most consecutive days above 110, and that ended on the 30th of July. And they had a lot of record days where it was above 105 degrees. It was 56 days over 105. So it was really hot. But a lot of people will say, well, Phoenix is a big city, got a lot of concrete, it's a heat island. And that is true, but it actually does affect people who live there. It's another case of eco-modification where these urban areas become heat islands and they make it difficult for people to live. And so a lot of people say you can't use, Phoenix as a guide, because it's overly hot. But yeah, but that's true, but it really is also a place where people live. And so it's a serious issue as we continue to get big urban centers in our southern cities. So in summary, it was a hot summer with significant events, which is normal. The dominance of ridges in the United States related to the fires and smoke. The southern U.S. had heat and severe flooding, mainly over the top of the ridge. And the Pacific had this windstorm that ended up being the famous now or infamous Maui fire. And I think the Maui case and even Phoenix kind of shows that the impact of eco-modification by humans, like the Leahana fires, where we probably would have just had a big windstorm had we not had all the invasive grasses and had the power lines been fixed. So there's in meteorology and climatology kind of played a small role, and the eco-modification played maybe a bigger role in this particular event. And that's probably true of Phoenix and other cities where it gets ridiculously hot for long periods of time. Thank you.
Thank you, Rich. Really good, comprehensive talk there. So hopefully that will drive a lot of questions. I know I have questions, but before we get to the Q&A, I'd like to introduce Bruckner Chase, founder of Ocean Positive Foundation, global ocean advocate, professional surf life-saving athlete, endurance swimmer. He calls Ocean City, New Jersey home. I've spent many summers in my youth in Ocean City. And Bruckner trains local ocean lifeguards, and we're almost going to give him a honorary meteorology degree with all of the lightning safety he's been doing recently on the beaches and everything. So Bruckner, we've talked 2 AMS weather band webinars on beach safety, rough surf, rip currents. Please talk about the summer and the good and the bad.
Yeah, I'd love to. And it's great to be here. And technically, I'm in Summers Point, New Jersey, but I do call South Jersey kind of my home ocean. But, you know, because of a lot of the stuff that I get to do in and around the ocean, I also get to call Wallula Surf Lifesaving Club on the Sunshine Coast of Australia home. I get to call Santa Cruz and Monterey Bay home. So I've gotten to spend some time with some great communities and in some great ocean areas. And I think that it has really helped to shape how we talk about ocean safety, as well as recognizing the differences of different areas. I got involved with the American Meteorological Society through my work with the National Weather Service and developing the Wave Safe film series with National Weather Service, where we took a demographic and geographic look at coastal safety, recognizing that the beaches on the Outer Banks of North Carolina do not look the same way or function the same way for visitors as the beaches in the Pacific Northwest, Southern California, Hawaii, or American Samoa, another place that I call home. And so what we wanted to do is really kind of help people understand, raise their blue IQ, so that if they are living at a location that doesn't look like the Outer Banks or visiting a place for the first time, they had the tools to evaluate what was going on in the ocean right there. And one of the things we've talked about is really where weather, water, and waves meet, and how dangerous that can be if you don't respect that water and the impact the weather can have on it. And one thing that, you know, it was a really tragic start to the summer in the panhandle of Florida, with a lot of drownings, some due to rip currents, some due to tidal currents, some due to people not understanding how their swimming ability translated to the ocean environment. We're tracking with a really high number of deaths again this year in the surf zones. And what we'd like to do is decrease those. But one of the things that really kind of struck me as we did a lot of presentations with American Meteorological Society at the Broadcasters Conference, which led to doing some pieces with the Weather Channel, is too often we'll say, well, it's common sense to not do this in the ocean or not to do this at the beach. And the mistake with relying on common sense is that it really requires a shared common experience. And that if someone doesn't have an experience with waves or with deep water or cold water, it may not be common sense. And so what we really want to do as communicators and people just kind of looking after our own families or communities at a beach visit is really understanding what those conditions might mean for us, what it means if the wind is blowing strong from my back or hitting me in the face as I look out at the ocean. What might that mean to the conditions that I might find? And how quickly do I need to start seeking shelter if I hear thunder or if I see a forecast for afternoon storms? And one of the things that's really important is we hear a lot of conversation on news programs and stuff about fatal drownings. And what most people may not recognize is there are fatal and there are non-fatal drownings. Drowning is a process. And a fatal drowning, obviously, is what it sounds like. Someone actually dies because of a drowning process. But non-fatal drownings or incidences in that near-shore environment can have a much larger impact. So if we have perhaps 100 fatal drownings, according to the CDC, and this is surf zone drownings, according to studies in Canada, the number of non-fatal drownings that could still require hospitalization could be 4 or 5 times that. And so the fact that it can be non-fatal, it can still have a traumatic, life-changing impact on an individual or their family or loved ones. And those collateral impacts are something that we really want to recognize and factor into. We want everyone to have safe and positive experiences every time they visit the beach. And so what we want to look at is not just understanding how to get out of rip currents, and understanding how to get out of a rip current is good, but we also know that you'll survive 100% of the rip currents that you never get caught in the first place. And understanding that rip currents are one hazard at the shore, but there are also tidal currents, as we saw in dramatic rescues and drownings in Florida that were at the entrance to an outflow from a bay. We had those types of inlets in the South Jersey area where the current from an outgoing tide can run much further and much faster than even a rip current. And just the near shore environment, where as waves wash up onto the beach and wash back, there can be an outflow of water that's not a rip current, but can still put someone into dangerous conditions, or conditions that are literally and figuratively over their heads. And so one of the things we're trying to focus on, and this year was kind of case in point for that, is raising people's blue IQ, which really gives them not just the knowledge of certain things going on at the ocean, but the wisdom and capacity to make good decisions when they're confronted with those experiences. Knowing that even a 3-foot wave may not look very large if you're standing on top of the dunes looking down on it, but can be terrifying if you're in the water and trying to swim out or back in. And especially if it's a small child that's with you, a 2 or 3 foot wave may only hit me on the knees, but for a 4 or 5-year-old child, it can rapidly knock them off and pull them into a situation where panic or a gully where the water's deeper can quickly turn into a life-threatening experience for that child. And then too often, and this is really significant, and why we have this Take 10 video that I'd encourage everyone to take a look at with National Weather Service, is drowning for love. And that's second victim drownings, where someone gets into a problem in the ocean, either with a rip current or overcome by waves, or they find themselves in deep water, or their interpretation of their ability to swim doesn't translate into the conditions in the ocean. A loved one, family, friend, bystander may run into the ocean to save them, and they end up in trouble as well. And that's a dramatic experience for lifeguards, who often are focused maybe on a primary victim if it's a guarded beach, but not knowing that there may be other people in the water. So those second victim drownings, we want everyone to be able to assess a situation to maybe stay out of the water, but if they see someone in trouble, what can they do to help them and save themselves, which is take an emotional pause to call 911 and alert someone else. Look for something that floats or will allow you to reach and assist someone. But bottom line, stay safe and try to encourage that person in the water to relax, so that waiting for professional help to arrive, but we want everyone to come out of the experience positive, alive, and ready for another great beach visit. And I think that's kind of what I wanted to pass along, that really understanding that assessing your swimming ability versus how it translates in the ocean may be two very different things. Or a large Great Lake, if you're up in the Chicago area, large bodies of water with dynamic conditions that were dramatically impacted by wind, waves, stuff will create situations that many people are not prepared for. So raise that blue IQ, use the National Weather Service tools, and let's, for 2024, have fewer drownings associated to coastal environments that people weren't prepared for.
Amen to that, Bruckner. That was a really good summary there, and just pulling up the National Weather Service statistics, and again, sometimes getting robust, accurate statistics is a challenge, especially in sort of the final determination of what caused the drowning. So far in 2023, 82 fatalities, spanning from Puerto Rico, into the Gulf, up the East Coast, and even in the Great Lakes, and a few on the West Coast. Much fewer, but still a few on the West Coast.
And I think I'm actually looking at like 87. I think that 82 of them are attributed to rip currents, and often things are attributed to rip currents, even though there wasn't necessarily a witness there to actually evaluate whether or not that actually was what it was. And I think where we're seeing these clusters, like in Florida or on the East Coast, often is in very heavily tourist or visitor-driven areas. The Panhandle of Florida being that, where people unfamiliar with coastal conditions come down, don't accurately assess how the conditions translate to their capacity, and end up in trouble. The football player early in the summer who was just trying to swim out to a sandbar was in a deeper section of water and was just, beyond his capabilities. And often for data, I like to look at what Surf Life Saving Australia is doing, because they are a national organization with a lot of control over 317 surf life-saving agencies. So they capture really solid data on what people are doing and what they're able to do. And their study from 2022 found that 46% of people visiting the ocean could not swim 50 meters without touching the bottom, which means if you're in a rip current and you've got to swim 200 meters to get down the beach and back in, you're going to be in trouble.
Yeah. No, we definitely, in our outreach and education, you can't compare even your swimming ability in a pool, crystal clear water, marked, sort of predictable water depths, no currents. That's very different from a dynamic ocean environment there. Thank you, Bruckner. So I'd love Robin and Rich to hop on the video as well here as we transition to the Q&A. For everybody attending, if you have a question, do not hesitate. There is one question, Bruckner, on connecting the tropical system Hillary, because it was so unique to the Southwest and to Southern California. Did you see any, were the coastal residents along the coast there, were they aware and, heeded the warnings? Or were you seeing people kind of not prepared because of the uniqueness?
Well, Katie, I think it's a really good question. And to take it beyond just Tropical Storm Hillary, I lived in Northern California, have spent a lot of time in Southern California as well. And I found that for a lot of reasons, many of the people that were at the ocean or by the shore in California in those sections recognize dangerous surf, or more aware or primed to that than some visitors on the East Coast. We had some substantial storms come through the East Coast towards the end of the summer, and I did some appearances on the Weather Channel to talk about what to do before those. And I think that absolutely tropical storms and hurricanes that are creating, that may be way offshore, but creating very large nearshore conditions. People see a beautiful weather day and don't understand how dramatic that ocean condition can be. And I think that's what's really important, not just looking at the weather, but also looking at the local weather forecasting offices forecast for nearshore advisories like small craft advisories. Because while the weather may say sunny and 70, the small craft advisories may pick up on rip current warnings, wave warnings due to offshore storms, whether it's Hillary on the West Coast or here.
Yeah, you may hear some people refer to, hurricanes and other tropical systems that aren't threatening landfall as fish storms, and we're starting to frown upon that term because of the, long distant impact to surf conditions, even 1,000 kilometers away. You can still have a dangerous situation. It's not exactly a fish storm to those people who may get in trouble. So thank you for that, Bruckner. Robin, I alluded to this in the preamble about the historical snowpack and sort of the double-edged sword, and I wanted to get your insights as to looking into the future here. Obviously, it's a good thing. Snowpack, it's not rain where it just kind of either goes into the ground or goes off as runoff. It's a slow melt, but are we reloading the powder keg, so to speak, with the lush vegetation? We might get a flash drought next year. Sort of how do fire managers sort of look at the landscape now that we've got almost too much of a good thing with the snowpack?
Yeah, so you raise a good point, and some people joke that if it's dry, it's bad for fire season, and if it's wet, it's bad for fire season. And it's in some respects that's true, right? This year we saw the right recipe for lower fire behavior this year, right? Which was a deep snowpack that was combined with rainfall, and rainfall on snowpack, kind of works like a sponge, right? So you just have a really high water amount in that snow, and then it melted very slowly, and it got really to seep well into the soils and well into the fuels, and that increased those moisture levels, and that was the impact we saw this year. But the other impact that we didn't really realize was all of the what we consider fine fuels, which is the grasses and the brush, all of those that grew this year with the rains that came in the springtime. And so, yes, to answer your question, yes, we will see the impacts of those in future years as they dry out and become fuel for fires in the future. So, short-term benefit, right, for this year. But that's a pattern, right? And this is the ecosystem. Fire is part of our ecosystem. And that's something we need to, as a nation, come to grips with, right? This rains and fuel and grasses and brush that grow and fires, those are all part of our ecosystem. Where we need to get to a place as a nation is that we're managing that ecosystem in a healthy way so that our fires don't become destructive, but are rather doing their duty, if you will, to really clean out those finer fuels as normally would in nature.
Right. It's very similar to the beach interface. You have that wildfire interface where we're sort of encroaching in on that natural cycle. Rich, I'm looking at you for this question from Scott, with Katie's second question here, and then we'll get to Scott. Do we think that this year's unusual climate patterns reflected climate change, El Nino, both, something else? What do you think?
Can you hear me?
We can.
Can you hear me?
Yes.
Okay. Well, clearly there's a background climate signal that the atmosphere is generally a little bit warmer. So all our summers are generally warmer than they were, say, 10 or 20 years ago. And most of the people are familiar with the general patterns of how El Nino affects like the cold season weather. But actually, there is actually some research that kind of suggests that when you've transitioned, and we did a transition. I actually looked at the sea surface temperatures. We kind of transitioned in the May, June timeframe from La Nina to El Nino rather rapidly. And basically, for most of the United States, the short answer is that probably, yeah, there is an impact when you have an El Nino during the summer. And basically, one thing that El Nino tends to do is it doesn't have a really strong climatic signal, but it tends to make it drier in the northern areas of North America due to the shift in the jet. So the sea surface temperatures affect the large scale pattern, and the one weak signal is that it can affect the flow in the United States over North America and make it drier. And I think that dryness probably may have fed back with the overall climate signal and made a really dry, hot summer in Canada, which contributed to some of the fires. But El Nino doesn't have a real strong pattern that we associate with distinct areas of wet and dry and cold and over North America that we see in the winter. But that one thing kind of does, that one signal may pop out.
Great. And then Robin, looking at you, I don't know if you were able to look at Scott's question, but if you take, yes, it was reduced at least in the lower 48, but what about if you include Canada, what kind of season do we have? I mean, obviously Canada, much larger landmass.
Yeah. So it was a record season in Canada, right? They had significant fires for extended periods of time. And I don't have the numbers at my fingertips, but even if we did try to pull them together, it's a little bit of apples and oranges because of management strategies, land management strategies, well, and fire management strategies that differ between the United States and Canada. But yes, there's no denying that they had a significant wildfire season. And if we totaled the two together, we would be much more tipping the scales to an above normal overall look.
Great. Anybody else? I'll throw one for Bruckner. It was, and again, it kind of reiterates some of the themes that we're talking about with, every beach fatality is tragic. It hits me hard. I don't know if it's the fact that most, you're on vacation, you're trying to enjoy yourself, you're with your family, and the last thing on your mind is that you are in danger. Obviously, there are so many great things about going to the beach and enjoying the water. Again, it's, like going to an amusement park, there's safety features that you have to be cognizant of and not always just assume you're perfectly safe. One of those instances this summer was Ryan Mallett. And for those who may know Ryan Mallett, he was a star quarterback for the University of Arkansas football team and was in the Destin area. And just reading the news reports today, looking back on that, wasn't rip current related, but was a sort of decision to go out to a second sandbar and then struggled to come back in. Is that a common occurrence that you're seeing, that it's just sort of risk taking and just, that type of situation?
I would say that I think it's a very common occurrence, and I would not even say that it's risk taking, because in my mind, risk taking means that you acknowledge there's a danger and you're taking a risk. Whereas if you go, I'm just going to swim out to that sandbar and think that's well within my ability. And I think with my experience, and I recently did some work with Rice University's, working with their athletic department and doing a talk around coastal issues. And, had a lot of football players going, man, I can't, the ocean and that stuff, that's another world. So these are, athletes that are recognized, they're strong, they're fit, they're masters of their domain on the football field. But in the ocean, it's a different element, it's a different environment. And you can learn to swim lessons when you're a kid, but in that environment, it's completely different. We run an adult ocean swimming program. We take adults out every week, to train. And I would say that the people I assist back to shore the most are people with that program that come to the ocean because they want to learn how to swim in the ocean. They do it in a safe environment where we've got lifeguards there, and we're there to help them get back in and learn how to judge the waves as it impacts their ability. But I see so many people that check every box of being an experienced swimmer, get hit by the first wave or get offshore a little bit and go, I don't know what to do right now. And I think that his story should really land with a lot of people that are visiting the beach. They feel that they're fit and in control, but always respect the ocean. We teach coastal safety around three things: a philosophy of respect the ocean, a mindset of staying situationally aware to changing conditions, whether it's lightning or wind changes, and then the take 10, protect yourself to save others. And I think whether you understand the ocean or not, if you start off with, I respect this, I think that's going to help save a lot of people. And that comes back to the blue IQ idea, the wisdom to make good decisions before you end up in trouble.
Right. Well, we're coming to the top of the hour. I guess in my final observation with the three of you is, in many ways, many of these instances in the summer of 2023, if you're a tourist, if you're going into an area where you're not, you didn't grow up there, you're not familiar. It could be the beach. It could be a resort vacation destination like Maui. It could be a national park, in the Great West there. There are a lot of things, a lot of preparation, a lot of techniques that people need to be aware of in ensuring their safety and ensuring that, issues don't rise up like a campfire and fire spread from human activity. I think we saw that in all of these talks, where there is a personal responsibility that we all have, that we can continue to pound the education and outreach across the country. So thank you to all three of you. Gideon, back to you as we wrap up this very fast hour.
Well, thank you very much, Doug. And Robin, Richard, and Bruckner, thank you again for taking the time to join us this evening with your very important insights and observations, and just points for our audience to take home with them. Audience, all webinars will be available to Weatherband members at amsweatherband.org. And yes, if anybody has any further questions, or if you'd like to discuss this more, please feel free to do so on the Weatherband Community Forum. With that being said, again, once more, thank you to our panelists and our moderator. And everybody, have a great and safe evening, and we'll see you in the next AMS Weatherband webinar. Good night.
Thank you.